Alright folks, so we're going to continue on our completing the square. So this part wants us to determine the vertex of a quadratic function by completing the square, and we've got this function that's here. And so it does ask us to do a couple of things that are in here. So I'll get you to pause the video, try out the question, and come back when you're ready to go through it. Alright, so if we consider the function y is equal to 5x squared plus 3x plus 41, we have a certain amount of steps that we need to do here when we complete the square. So we're going to basically go through what we know for our steps, okay, on how to solve this. So if we started off and we have our function, y is equal to 5x squared plus 30x plus 41. So I'm going to group together my first two terms. And then I'm going to make sure that my x squared term has a 1 in front of it. So I'm going to factor out the whole 5 here. So x squared plus 6x. Then I'm going to do that completing the square step. So I've got half of my b value, which is 3. 3 squared is 9. And then I have to remember to add and subtract it there. And then here comes that term where this value, where this value multiplies into here. And I have to remember that in order to take the 9 out, and I take half my b value, square it, 5 times 9 is minus 45. And so y is equal to 5, x plus 3 squared minus 4. Okay, now it says complete the square to determine the vertex and the maximum or minimum of the function. So here what we can see is I can see the vertex here is negative 3, comma, negative 4. And I can see that because this thing opens up, so if I'm visualizing where this is on a graph, I'm over 3 and down 4, and it opens up. Right, that means that it has a minimum value in the function, and the minimum value is the y value. So it has a min, and the min is at y equals negative 4. So we can see kind of that completing the square step going through here, and then I can tell what the vertex of the max and min are as well. So then it says using the process of completing the square to verify the relationship between the value of p in vertex form and then the value of a and b in standard form. So if we were to take a look here and see what we're doing in this question, we're always factoring out our first term. Okay, so we're always factoring out a. All right, this is our kind of our step after we group these together, right? So really, this value in the middle becomes like b over a if I were to factor this out. So I guess what we're kind of getting at here is this part right here. So let's visualize that we have ax squared bx, and then you can see when I factor out the 5, do you see how this becomes 6? So really what happens here from my original equation is that when I factor out the a, I'm left with x squared plus b over a times x. Right? That's my first step that I'm really going through there. So divided this gives a coefficient inside the brackets, and it makes 6 is 30 over 5, or it's b over a. Now, after that, remember we did this whole completing the square step. Half that number squared. So if I take half of this, picture going b over a divided by 2, which is like saying b over a times a half, which is going to equal b over 2a. Right? So half the coefficient of the x inside the brackets gives the value of p in vertex form. And basically, it's saying, hey, p in vertex form here is really b over 2a. But we kind of already knew that we could find the axis of symmetry if we did negative b over 2a. Right? Considering the steps in completing the square, the value of p is equal to minus b over 2a. So for any quadratic function in standard form, the equation of the axis of symmetry is something that we've already investigated. And then we know that we can actually find the y value from there and take it a step further by plugging this back into the equation, and that will tell us what the y value is as well. So determining the x-coordinate of the vertex, notice how here the minus b over 2a part, I can see I'm getting my -3, and I can see from my equation here, there's my -3. So determining the y-coordinates by subbing it back in, you see how we can sub this back in, which we've done before. I get y's -4, which tells me the max or min value. So this is the same as the coordinate that we determined in part A. So hopefully now we can make that connection on how we can calculate axis of symmetry and find the vertex as well in standard form by doing this minus b over 2a bit as well. So it's just being careful in terms of solving and following along with what it's kind of asking you to go through. So I do have some problems for you to work on with this part, and if you have any questions, please let me know.